in this lecture, we're going to be talking about our local wind systems. So before I get started, I just want to point out that all winds are named for where they're coming from. So if you are sitting and trying to remember the difference between a sea breeze and a land breeze and which one is which, always remember that the name for the wind tells you where it's coming from. So if you have, for example, a north wind, I'm going to sound like I'm talking about Elsa. I think they had a north wind in that movie. Anyway, a north wind is one, if we have north up here, it's one that's moving south. It's coming from the north. Okay, so all the winds are named for where they are. If you could even make up winds. You could have, a west wind would be moving from the west to the east. Okay, so that would be our west wind. Okay, if I wanted to make myself a wind, I originally was from California, so I might be a California wind. I was a wind that came from California, but I'm not a wind. So let's actually talk about some real winds. We're going to start by looking at our mountain and valley. So mountain and valley breezes. So mountain and valley, it's easiest to kind of draw this out. These are going to be side view pictures. So these are our mountains. If you want to put yourself in a place, might think of Colorado. These are places in the daytime. We have our happy sun. Okay, that sun is going to start to heat up our higher elevations. So this is the daytime. Okay, it's going to start to heat up our mountaintops. Okay, as we start to heat the air, it's going to cause that air to rise. Okay, so that creates a low pressure on top of our mountains. Okay. And that means if we have low on top of the mountains, we're going to have a high pressure in our valleys. And we know that winds move from highs to lows. Okay, so this is a creation of a valley breeze because it's coming from the valley. So this wind is a valley breeze. Okay, now what happens to this breeze? As it moves up the slope, it is moving upwards. It's going to start to cool. So it cools as it rises. Okay, and that cooling leads to adiabatic cooling. That can create some clouds and afternoon thunderstorms in the mountains. So if you are in a mountain area, in the summertime especially, you should always be prepared for a potential thunderstorm if you get out because of these just daily changes in air movement with that valley breeze. Okay. Now at nighttime, we're going to create, it's the same mountain range. If I can draw it, so we have our mountain, our valley, another mountain. It's now nighttime. I guess I have to do this in blue. So nighttime. Well, what starts to happen, if you've ever been up in the mountains, you know that it cools off pretty quickly. So this is going to cool off. The air is going to cool and condense. It becomes denser and it starts to sink down into the valleys. Okay, so that cool air sinks. So it's cool, sinking air. Okay, and it's going to end up inside of our valley. Now we know because the air here, this is going from a high to a low. Okay. Yep. So these are our mountain breezes because they're moving from the mountains to the valleys. And these mountain breezes tend to be stronger in the wintertime. And that's just because of the difference in the temperature. Okay. Now the next one that we're going to look at are coastal breezes. So these are called sea and land breezes. Okay, so this is going to be another side view, and we're going to draw this kind of like this, and there's our ocean. So this S and L stands for sea level. It's just an S with an L through it. So what happens, again, we're going to be starting out looking at our day, and draw a nice happy sun. So in the daytime, our land heats up faster than our oceans. The reason this happens is due to the heat capacity of water. So we just want to remember that water has a very high heat capacity. And that just means it takes more energy, more time to heat up the water than it does to heat up the land. So land has a very low heat capacity. It heats up and it cools down very quickly. It's like a pan that you might set on your stovetop. The metal, when you touch it, it's cool. As you start to add heat to the bottom, the metal heats up very quickly. It makes it very good for cooking your materials because you're going to be spending less time heating up the metal to cook your food. So land heats up and cools very quickly. Water does not. It takes a lot of energy to heat up water or to cool it down. And you know that also from cooking when you try to boil water. It takes a long time to get it up to its boiling temperature. Okay, you have to add a lot of heat before it starts to boil. So during the daytime, the land heats up. Okay, that causes the air to rise. And if hopefully you're remembering it, when air is rising, that means we have a low pressure over the land, okay? And then we're going to have a high pressure that's going to be established over our ocean. And since air flows from high to low, okay, air moves from over the oceans onto land. This brings a nice cool breeze onto the ocean. So that will also blow clouds. You kind of get some nice clear weather. And so this brings cool air onto the land. Okay. This is called our sea breeze. Okay, now just be careful because some people do call this an onshore breeze or wind. I find that name very confusing because we think of shore kind of as land, but just remember this is a sea breeze because the air is moving from over the ocean to the land. Okay. Now at nighttime, I'm going to draw our same area. Okay, so we have our ocean and we have nighttime. So at night, for the same reason with that heat capacity, our land is going to cool off. Okay, that establishes a nice high over the land and a low over the oceans. Because the heat capacity of the ocean hasn't changed, it's still got warm air over the top, and so the air is now going to move from the high to the low out to sea. Okay, and that is your, land breeze. All right. If you're trying to wonder where this tends to happen, is it at every single ocean location? No, they tend to occur mostly in the tropics and mid-latitudes. And they tend to be for the mid-latitudes where we have cooler ocean temperatures. They'll be in other places, but they'll just be a little less pronounced. All right, now we're going to look at Chinook winds. So Chinook winds. Chinook winds are associated with the Rocky Mountains in the United States and in Canada. They're also the same thing as the Foehn winds. And I have seen them spelled this way. Okay, and these are just where they're occurring in the European Alps. Okay, but our Chinook winds, again, are common in the Rocky Mountains. You can see them in Colorado, and then they're also very strong up in Canada. So I'm going to draw a system in Canada. So we have Alberta is out in the east, and we have British Columbia, and we have the Rocky Mountains between them. Okay, the mountains are very pronounced, and then British Columbia touches the Pacific Ocean. So what's happening is that here the wind moves from west to east, and it takes air from over the oceans, and it moves it up and over the Rocky Mountains. This water, because it is over the ocean, is warm and it's moist. So it's carrying lots of moisture. It's coming across British Columbia. We do get that humidity helps drive agriculture in this area. As we come up into the Rocky Mountains, the air is going to rise. It's going to cool adiabatically, and it leads to precipitation. So as it goes up, we're going to start to see some clouds and some precipitation. So that's falling here. Up and high, we'll start to see it falling as snow. Great if you want to go skiing. Okay, so it's dropping all of this moisture. This is the rain shadow effect. Okay, so something that we've seen. And then it screams up and over the Rocky Mountains, and when it gets to the top, it's going to start to descend. Now, as it's descending, it has less moisture, so it's dry. As it descends, the air molecules get pushed together. It's going to warm up a lot, and it's going to move really fast down through this area. So we have dry, warm air, and it's fast. I wrote down some of the speeds because I can't remember it. So the winds can be up to 120 kilometers per hour. And the air temperature can change. So we can see a 20 degrees Celsius change in temperature. So the temperatures can warm up very, very quickly. Because that air is moving so fast and it is so warm, these are called snow eater winds. In the winter time, as they move through, if there's snow on the ground, you'll get some evaporation, but also, gosh, the word's just not in my head today, sublimation. And sublimation is just the process where we go just straight from ice to vapor without going through a liquid state. So we get both evaporation and then sublimation, and that snow starts to go away. So some things that we start to see, we do see clouds over here. We will see some clouds kind of over the mountains. They tend to kind of stay in the mountains, and then the Chinooks Sometimes you'll start to see these kind of flat clouds. They call them Chinook arches, and that's just they can be undulating a little bit, and they're just associated with these Chinook winds. And they kind of say that, hey, you've got some nice weather that's going to make some of that snow go away. All right. Now we're going to talk about a wind that I am very familiar with growing up in Southern California, and these are our Santa Ana winds. And if you're in Northern California, they do call these Diablo winds. They are just different names for the same thing. So I'm going to try to draw out a map to get a sense of where we're looking at. So this is really just a difference. Kind of draw my state. And then Arizona kind of comes down. Let's see, Utah, you have a big hook. That's Colorado. So we have Colorado, Utah, Nevada. This is California, Arizona, and New Mexico. Apologize for the shapes of things. They're not perfect. Down here, this is Baja California. And then this is Mexico. Okay, so the places we start to see Santa Ana winds, they're associated with Southern California and Baja California, and then you can see the Diablo winds up in Northern California. So what's happening? These tend to occur in the fall to spring, so they can go all winter. But they're pretty strong in the fall a lot of times. What happens is we start to see a high pressure forming over the high deserts of Colorado and Utah. So here the air is very, very dry, and it tends to be cool. So it's going to be around 10 degrees Celsius. So for all of my non-Celsius people, that's about 50 degrees Fahrenheit. This cool, dry air, it's at a high pressure, it's going to spread out and away from the high towards the low. Okay, so we have a low pressure and air flows from high to low. Now we're going to take this dry air. It is at a higher elevation. So if you can't remember, you don't know your geography, we do have mountains through here. There are mountain ranges that go through Nevada, and then Utah and Colorado, they're sitting on the Colorado Plateau. They're much higher up. So we have our big Rocky Mountains out here, and then the Colorado Plateau sits above as well. So this air is higher up. It's cold, it's dry, and it's dense, and it's going to be moving towards that low, and it's moving from a high elevation to a low elevation. As it moves down, it's going to warm up, it becomes compressed. Let's see, so where do I want to try to write all that? The air is becoming compressed. Okay, so it's warming adiabatically. And it was dry to start out, so it becomes very dry. Okay, as we warm the air up, it can hold more moisture, so that the relative, it just goes way, way down. So it's very, very dry when it comes through here. And then it's moving down the mountains. These winds start to move very, very quickly. We start to see the winds can be very high, just like our Chinooks. And the big problem, so as these kind of come through, they come screaming through the mountains up in this way as well. This warm, dry air, it's happening in the fall to spring. This really promotes wildfires. So if you have a spark that happens naturally or because of people, the winds, the dry air, these are all the factors that we need for fire. So they are associated with very high wildfire risk. And it's just because of this natural system, this just happens. So it very much increases our fire danger, and it can cause a lot of problems, especially if it's happening on top of periods of drought, which can happen in this area as well. All right. Oh yeah, when the air gets out here, I just want to forget, if you're kind of wondering why I wrote 10 degrees Celsius, as the air comes here, it can get up to 50 degrees Celsius, which is like your 90 degree Fahrenheit. Okay, so very warm and very dry. All right, and our last one, 2 more to go to. All right. Okay, so the next one that we're looking at are Katabatic winds. These are gravity winds. And these are associated with Greenland and Antarctica. Okay, so these are places where we have really high glaciers. Okay, so we have a high elevation and lots of ice. So glacial ice. The air above this is very cold and very dense. Okay, but it's sitting at a high elevation and gravity is pulling it down. Okay, so as gravity is pulling down, we start to get a pressure gradient force. And we have the air is going to move from the high pressure to the low pressure down this slope. Okay. These are going to move very, very fast, and they're very, very cold. So these are very cold and very fast. They can have like hurricane strength winds up to 300 kilometers per hour. Okay. Down here we are going to see the air warming a bit because it is moving down slope. So it warms adiabatically, but because it was already very cold and dry to start out with, it's still cold when it gets down to the bottom. The wind is the green line, so that's your Katabatic wind. So we're taking this very cold, dense air. It is moving down slope, so it will warm adiabatically, but it's still going to be cold when it gets down to the bottom of this valley. But the warming allows the air to hold more moisture, and that can sublimate some snow. So again, these are very cold, very fast winds that can move up to 300 kilometers per hour. Okay. All right, the last one that we're going to look at are our monsoons. Okay, and monsoons happen in our tropical location all around the world, but today we're going to just look at India. It provides a nice kind of example. Okay, so we have India, and then we have the Himalayas, part of the Tibetan Plateau. Okay, and then we have our Indian Ocean here with our sea level. All right, so in the winter time, that's where we're going to start out. What we have is a high pressure over the Himalayas, and we have a low pressure over the ocean. So the air moves, let's see what, air moves from high to low. So as it moves down slope, it's going to warm up from adiabatic process. That's going to soak up any moisture, so it becomes dry, and it's going to move out to sea. So this high that we're looking at over here is the Siberian high. Okay, and it's shifted up over the Himalayas at this time. Okay, so this leads to nice dry air kind of moving down, and this is the dry season. Okay. All right. Now what happens in the summertime, I'm going to leave this up as a comparison and just draw summer down below. Okay, I'm going to do my best to make it look. Okay. Okay, so that looks more or less the same. What happens in the summertime is our low pressure is over the Himalayas. This is where our ITCZ is, and it's moved over the Tibetan Plateau over the Himalayas. Okay, so when we have a low pressure system, we remember that the air is rising. Okay, as the air rises, it's going to be replaced by air coming from the high pressure. So air flows from high to low, and we're going to take all this moist air from our oceans, we're going to move it onto the land and force it up the mountain. So we have some orographic lifting, and we have some really warm, moist air flowing onto the land. As it's lifted, so we have orographic lifting, okay, that causes the air to cool and condense, and it leads to some really heavy precipitation kind of flowing down the mountains. This can lead to really intense flooding in the lowlands and lots of rainfall. It can create a lot of problems, and it also leads to snowfall high up in the mountains. Okay, and so that's just the change in seasons. It's hard to predict because it does depend a lot on where the ITCZ is going to be and movement, so it's not exactly predictable, but there is a seasonality to it that you can see in the the winter and the summer months. And so those are all of the local winds that are good to know to understand wind movement on our Earth.